Hey everyone, we've got an easy one for you today. We're going to be doing some square rooting and taking a look at how this applies with some geometry problems. So let's go ahead and get started. These questions, of course, are meant to coincide with your assignment. This one happens to be Punchline Bridge to Algebra, page 113. We're going to start with a few of the concepts here first. So we're looking at the area of the square for a lot of these problems. And so this is probably the most basic formula for area that you're ever going to get, especially in geometry. So the area is just the side squared, which of course is a fancy way of saying side times side. So if I have this as my square, I've got the two sides, I've labeled them S, then the area is just going to be equal to the side squared, which a lot of times you would see as area equals S squared. Which remember, that's the same thing as area equals side times side. Or sometimes you see this as A equals S squared, which you could probably have a lot of fun with if you're creative. But today we're going to take a look at examples of this. So this isn't actually from your work. This is just an example of how this works. So if you have a square and the two sides are 6, then we're going to apply that same formula, area equals side squared. And instead of a side, we're going to write a 6 because the side is 6. 6 squared is, of course, 36. And that really quick gets you to area equals 36 really fast. Another way you might see this is, what about if the area is 64, but we don't know how long the sides are? So if we don't know how long the sides are, we actually use the same formula, area equals side squared. But this time, instead of substituting for the side, you're going to substitute for the area. So 64 equals side squared. Now the algebra comes into play because you're going to have to simplify, or you're going to have to solve with the square root on both sides. So the square root of 64 equals the square root of side squared. And of course, the square root of 64 is just 8. You can get that with a calculator if you need to. And the square root of S squared is just S. Now remember that property because that's going to come up again later. The square root of anything squared is itself. So the square root of S squared is S. Now we're looking at stuff from your actual work. This is problem T. There's a few problem T's. I think I got all of them. But here we're saying the area is equal to 100. So is that more like the first example or the second example? That's the second example, I think. So we're starting off with that same formula in this problem, area equals side squared. We don't know the side, but we know the area is 100, so 100 equals side squared. To simplify it, you're going to have to take a square root of both sides. The inverse operation of a square is always going to be that square root. So we're going to square root both sides, and you're going to get S equals 10. The square root of 100 is 10. The square root of S squared is S. S equals 10. So not a problem. Pretty easy, actually. Later on in the problem, we get another letter T. This time, they tell you the side is 25, and now you're supposed to find the area. And actually, this is the easier of the two problems. Start with the same formula, area equals side squared. Substitute what you know. In this case, we know the side is 25. And then do any arithmetic that happens as a result here. So you get area equals 625, and there's no actual algebra to do in this one, no solving. You just have to do some arithmetic. Again, if you don't know what the square of 25 is, you can just grab a calculator or ask Alexa or ask Siri, ask Google, doesn't matter. Area is 625. Now we're going to get into some of the simplification stuff that you're going to see here. This is a review of a lot of the stuff that we did before, so this should go pretty quickly for you. We know that the square root of 16 is 4 and the square root of 9 is 3. So we're free to make those substitutions freely. So if we start with the equation, we can substitute. Square root of 16 is the same thing as 4. Square root of 9 is the same thing as 3. And then 4 plus 3 is 7. Easy. Here's another problem. This time we have one square root, and inside the square root we have 100 minus 64. So the rule here, very important rule, is simplify inside the square root first. So inside the square root, we see 100 minus 64. We need to simplify that first. And that's not a problem. 100 minus 64 is 36. Calculator again, if you need to. And then the square root of 36, if you don't remember it, 6 times 6 is 36. So the square root of 36 is 6. Easy. Here's another one that's actually really similar. This time we've got the square root of 17 squared minus 15 squared. Okay, same rule. Simplify inside the square root first. And 17 squared is 289, and 15 squared is 225. Again, that's just arithmetic. Any arithmetic, grab a calculator, do it on the calculator. It's not a problem. 17 times 17 is 289. 15 times 15 is 225. More arithmetic, you're going to have to subtract those two results, leaving you with 64. And then square root of 64. You can do that with a calculator, or if you remember what that is, that's actually a perfect square. I had you guys write them all out a few times, actually. So the square root of 64 is actually 8, and the answer here is 8. Okay, a couple more for you. We've got this one, square root of 38 times the square root of 38. And I'd like to remind you that square root of 38 times the square root of 38, well, that's the same quantity being multiplied together. So that's the square. That's the square root of 38 squared. And of course, the square that you see over here and the square root, those are inverse operations. So I hate to say that they cancel each other out, but that's the way a lot of you are going to think about it. So the square root, or the square of the square root of 38, is just 38. They are inverse operations, so the answer is the same thing as the question, kind of. And that's it for us, everyone. Hopefully that was a lot of fun for you. I know that was a really quick one, but this is a little bit of review, so we should be good to go. And I will see you next time when we start applying this stuff to the Pythagorean theorem, which is an incredibly important theorem, incredibly important concept. Yeah, I'll see you next time.